Hello science fans. Today we're diving into the world of elements, but not just any elements. We are going to explore the most dangerous ones on our planet. What makes an element dangerous? Well, it usually comes down to two main things: chemical toxicity or radioactivity. Both can be incredibly harmful to living things, including us. It's important to understand these dangers, not to be scared, but to be informed and careful. Science is all about understanding how the world works, and that includes the parts of it that we must respect and handle with extreme caution. These elements are a powerful reminder of nature's hidden forces. First, let's talk about chemical toxicity. This is when an element acts like a poison. It gets inside your body and messes with your internal chemistry, kind of like a wrench thrown into a smoothly running machine. Elements like mercury and arsenic are famous for this. They can damage your nerves, shut down your organs, and cause serious illness or even death. The tricky part is that these poisons are often hard to detect. They can be tasteless, odorless, and colorless, which means someone could ingest them without even knowing it. This silent but deadly nature is what makes them so hazardous. On the other hand, we have radioactivity. This is a completely different kind of danger. Some elements have unstable atoms, meaning they are always breaking apart. When they do, they release tiny, invisible particles and waves of energy. This is called radiation. Elements like polonium and cesium are famous for being highly radioactive. If this radiation hits the cells in your body, it can damage your DNA, which is the instruction manual for how your cells work. This damage can lead to sickness, cancer, and other long-term health problems. Unlike a chemical poison, you don't even need to touch a radioactive element for it to harm you. The most dangerous elements combine these scary features. They might be easy to hide, hard to get rid of, and capable of causing harm in extremely small amounts. A speck of one of these substances, smaller than a grain of salt, could be enough to cause a fatal illness. Because they are so potent, they have been involved in accidents and even used as weapons. Understanding how they work is the first step in learning how to protect ourselves from them, and how to handle them safely when we need to use them for science or medicine. It's a fascinating and serious part of chemistry. Let's look closer at some chemical poisons, starting with arsenic. For centuries, this element was known as the king of poisons because it was a favorite tool for assassins. Why? Because it's very hard to detect. Arsenic compounds can be a white powder that dissolves in food or drink without changing the taste or smell. Ingesting it leads to terrible stomach pain and organ failure. In the 19th century, people were poisoned without anyone meaning to. A popular green paint used for wallpaper contained arsenic. When the wallpaper got damp, it released toxic arsenic gas into the air, making entire families sick in their own homes. Next up is mercury, the only metal that is a liquid at room temperature. It's shiny and fun to look at, but it's also very toxic. Mercury slowly evaporates, releasing an invisible odorless vapor. If you breathe in this vapor, it gets into your bloodstream and travels to your brain, causing serious nerve damage. There's a famous phrase, "mad as a hatter," which comes from real history. In the 1800s, people who made felt hats used mercury to treat the fur. They breathed in the fumes all day long, and many developed tremors, memory loss, and hallucinations from mercury poisoning. It shows how even everyday jobs could be dangerous. The danger of these chemical poisons is that they accumulate in the body over time. This means that even small exposures repeated day after day can build up to a deadly level. Your body has a hard time getting rid of them, so they just stay there, slowly causing more and more damage. This is why there are now very strict rules about using mercury in things like thermometers, and why we are so careful about arsenic levels in our water and food. Scientists have learned from the mistakes of the past to protect our health today. Detecting these poisons used to be nearly impossible, which is why they were used in so many mysteries and plots. But today, forensic science has changed the game. Scientists can now use advanced machines to test for tiny traces of arsenic or mercury in hair, blood, and tissue samples. This technology helps doctors diagnose poisoning and helps police solve crimes. While these elements are still dangerous, our ability to identify them has made it much harder for them to be used as silent, secret weapons. Knowledge is our best defense. Now let's switch to the invisible danger of radioactivity. Consider polonium-210. Discovered by the brilliant scientist Marie Curie, it is one of the most radioactive substances known. Its atoms release something called alpha particles. These particles are actually quite weak and can be stopped by a piece of paper or even your skin. However, if you swallow or inhale polonium-210, it's a different story. Inside your body, those alpha particles are released directly into your tissues and organs, shredding your DNA and causing rapid organ failure. A lethal dose is a microscopic speck, making it incredibly dangerous. A tragic real-life example of polonium poisoning is the story of Alexander Litvinenko. In 2006, this former Russian agent was in London when he suddenly fell ill. Doctors were confused because his symptoms were a mystery. After weeks of suffering, he died. Investigators eventually discovered that a tiny amount of polonium-210 had been secretly put into his cup of tea. The radioactive material inside his body slowly destroyed him from within. This case showed the world how a radioactive element could be used as a nearly undetectable poison, a truly terrifying modern threat. Another dangerous radioactive element is cesium-137. It's not found in nature but is created inside nuclear reactors and bombs. The danger of cesium-137 is that it spreads very easily. It dissolves in water and can be absorbed by plants, which think it's potassium, a nutrient they need. From there, it enters the food chain. A terrible accident in Goiânia, Brazil, in 1987 showed just how dangerous this can be. People found a glowing blue powder from a stolen, broken open piece of medical equipment. Thinking it was magical, they touched it and spread it around. This powder was cesium-137, and it led to several deaths and the contamination of hundreds of people. Major nuclear disasters, like Chernobyl in 1986 and Fukushima in 2011, released huge amounts of radioactive elements, including cesium-137, into the environment. At Chernobyl, a reactor explosion spread a radioactive cloud over Europe, contaminating land for centuries and forcing the evacuation of entire cities. In Fukushima, a tsunami caused a nuclear plant to leak radioactive water into the Pacific Ocean, contaminating fish and the marine ecosystem. These events are powerful reminders that the energy from radioactive elements must be managed with absolute care, because a mistake can have consequences that last for generations. So, if these elements are so incredibly dangerous, how do scientists even study them? They use very special equipment and follow strict safety rules. To handle highly radioactive materials, scientists use sealed containers called glove boxes. These are transparent boxes with thick gloves built into the sides, allowing them to work with the material without ever touching it. For even more dangerous substances, they use robotic arms that they can control from a separate, heavily shielded room. The air in these labs is constantly filtered, and scientists wear special suits and devices called dosimeters that measure their exposure to radiation. These safety measures are critically important because, despite their dangers, many of these elements have useful applications. Science is all about discovery, and sometimes the most challenging things can also be the most helpful. For example, the same radiation that can cause cancer can also be used to fight it. Doctors can use focused beams of radiation from elements like cobalt-60 to destroy cancer cells in a patient's body. Radioactive isotopes are also used to sterilize medical equipment, ensuring that surgical tools are perfectly clean and safe to use, saving countless lives from infection. Even some of the elements we've discussed have surprising benefits. Cesium-137, while dangerous in an accident, is used by researchers to study soil erosion, helping us protect farmland. Arsenic, the old poison, is used in tiny, controlled amounts in some specialized medicines and to make the computer chips found in our electronics. The key is control. By understanding exactly how these elements work and how to handle them safely, we can harness their unique properties for technology and medicine, turning a potential danger into a powerful tool for good. In the end, the story of dangerous elements is a story of respect. These substances teach us about the fundamental forces of the universe. They show us that things that are invisible can be incredibly powerful. By studying them, we learn not only about chemistry and physics, but also about responsibility. We have to be smart, careful, and forward-thinking. These elements are a part of our world, and while they demand our caution, they also fuel our curiosity and drive us to create new technologies that can improve and even save human lives. Think about that. Science is cool,